Lesson 4: Quality Control of Clinical Laboratory Tests. Your friend decided to buy a blood glucose meter to monitor his blood glucose level at home. You may ask, can the blood glucose meter provide accurate and precise results? What is the difference between the home test result and the laboratory measured result? How can we measure the quality of a test result? POCT point-of-care tests are the tests that can be performed at or near the site where the patient is. Usually, it is carried out at the emergency room, intensive care unit, doctor's clinic, or in patient's home. It is not necessarily performed by a medical technologist. For example, blood glucose test, pregnancy test, other common rapid kits, or point-of-care tests that we can perform it at home. This kind of test usually is easy to operate, only a few simple steps only. The sample volume is small, and the turnaround time to get the results is fast. However, the cost is expensive, and the performance of tests is varies, and there is lack of monitoring. Last time, we talked about the general workflow in pathology lab. We talked about before we do the analysis, we have to keep maintenance, daily check of the analyzer, and we have to do quality control to ensure the analyzer can give us accurate results. So that is a simple question. How can you maintain the air cooling function of the air conditioner in your home? I think you may clean and remove the dirt. You may check the temperature in the room to see if the air conditioner can maintain your desirable setting. If not, you may ask the engineer to refill the refrigerant. So, in the laboratory, we also need to maintain the function of an instrument. In order to minimize the chance of getting inaccurate or delayed results due to faulty instruments, expired reagent, or insufficient supplies. So we have to clean the parts of instruments, check the instrument setting, for example, the temperature of the water bath, the humidity of the incubator, the speed of the centrifuge. Also, we have to review the inventory supplies to ensure there is enough quantity of reagents and not expired. After maintenance and daily check, we have to do quality control. Quality control is some materials that is the same or similar to the composition of the patient sample, for example, plasma or urine. And this quality control have known results or values. So we can test it in the exactly same way as the patient samples. So it can detect the analytical error of the analyzer. The validity of qualitative tests, for example, pregnancy test kits. Reading the instructions, you may see that there should be a control line. If there is the presence of signal, meaning the control pass, it gives a valid result. If there is absence of signal, that means the QC failed. It is an invalid result. It can due to faulty kits or inappropriate sample. Quality control can also check the correctness of positive and negative reactions. For example, it can be used to check the ABO blood typing. We will have to check the test reagents, the antibodies, and also to control cells if they are still in good function. So we will test the anti-A with the A cells. It should give you a positive result, while anti-B should not have reaction with the A cells. In contrast, anti-A should not react with B cells, and anti-B will have a positive result with B cells. If we can get all these results, the QC pass. If the QC fails, we have to troubleshoot and find out the cause of error. In quantitative tests, quality control can check the accuracy of a numerical result. There are different levels of QC which covers a certain measurable range. If the QC results fall within the acceptable range, that means pass, the results are accurate. If the QC results are out of the acceptable range, the QC fail, the results are inaccurate. Take blood glucose test as a sample. There are two levels of control. Level 1, the target value is 6.0. If the QC result is 5.5, though it cannot meet the target value, but it still falls within the acceptable range, so the QC pass. However, in level 2, the QC results fall out of the acceptable range. That means the QC fail. No matter which one of the QC fail, we cannot proceed to test patient sample. We have to do troubleshoots, fix the errors, and then recalibrate the analyzer. So what is calibration? Think about when your clock is running slow, what will you do? You may firstly replace the battery and then take it to repair. And then you will adjust the clock regarding to a standard time. What will a medical technologist do when a QC fails? We will renew the reagents, repair the parts of the analyzer, and then adjust the test result based on a standard curve. Standard can be a reference device or a material with certain measurable reading. So in laboratory, we can check the accuracy of timer by compared to the standard time from Hong Kong Observatory. We can check the balance with calibration masks, and we can send the thermometer to the certified reference laboratory to check the accuracy of its measurement. After checking, we will do calibration. It is a process of adjustment of a measurement. Just like when your watch is running slow, after you change the battery, you will adjust the pointer towards the correct time. So how can we calibrate an assay in the lab? Take blood glucose test as an example. The reaction is based on we put a sample, it will react with the reagents and give the final color compound, which is a kind of signal that the analyzer can detect the signal and give you the result. So to calibrate this test, we can use different levels of calibrators. Each calibrator have a certain concentration. 0, 5, 10, 15, and 20. So this calibration with certain concentration will give out a signal. So an analyzer will plot these results and give us a standard curve. If it is linear, that means the signal is proportional to the concentration. After calibration, we can use the QC samples to check the quality of the assay. So now we will run the QC samples. For example, if this QC sample 1 give 5.7, while the QC level 2 gives 17.8. So both of the QC pass. So the performance of this assay is acceptable. It can provide accurate results. Then we will proceed to test patient sample. However, after a week, the performance of assay may drop due to run out of reagents or the deterioration of the parts of the analyzer. For example, the light intensity of the light source is weakened, so that the signal will drop. If we still use the old calibration curve by running the same set of QC samples, the results were getting lower. This time the result of QC level 1 drops to the boundary, but still pass. But the QC level 2 failed, so we cannot proceed to patient sample test. We have to do calibration. We have to run the standards again, so a new set of signals obtained. So after we have obtained a new standard curve, we do the QC again. When it passes, then we can test patient sample. This is what we do in the laboratory to ensure each assay can provide accurate results. To monitor the QC data, we will plot each of the QC run into a Levy-Jennings chart. Take glucose test as an example. Laboratory may run QC 3 times a day. So the analyzer will keep every QC value and present it in a Levy-Jennings chart. Medical technologists will review the LJ charts at a certain time interval, for example at 9 a.m. each day, so we can check any potential errors and correct it. For example, in this case, MLT may find that there is a dropping trend of measurements, and the results drop out of 2 standard deviations. So a corrective action has been made. So medical technologists will do some corrective actions to bring the performance of assay back to meet the target value. In laboratory, we will also set Westgard rules to monitor the QC values. When there is a QC pattern matched to the rule, the analyzer will notice the medical technologist to highly monitor the performance of assay. The QC data will also be calculated to check the precision of the assay. For example, in this case, the 10-day CV percentage is 3.3%, which is quite near to the expected CV percentage. So the overall performance of the assay is precise. So now, when maintenance, calibration, quality controls are all ready, we can proceed to sample testing. No matter how accurate an assay is, there are still some other factors that can affect the analytical results. For example, limitation of a test. For example, your body temperature thermometer, it can only give you a result from a range of 35 to 42 degrees Celsius. It cannot measure any temperature below or upper than the limits. So every analyzer or assay have its measurable range. So same to the other analyzers. Take blood glucose meter as an example again. If the results are lower or higher than the linear range of the standard curve, the results are incorrect. Environmental factors such as temperature and humidity may also affect the result of an assay. Actually, every analyzer and reagents were calibrated in a certain environmental condition before it is launched to the market. So we have to know there must be some restrictions. If we use it in an improper way, the results can also be inaccurate. And depends on the principle of the test. Some substances have similar chemical structure as the test material or reagent product the may interfere the biochemical reactions of a test. For example, blood glucose meter in the market may use different methods to detect blood glucose. If the blood glucose meter is using this method to measure blood glucose, vitamin C can be one of the interfere substances, can leading to a false higher level of results. In this lesson, you know how to maintain the quality of the test results and how to monitor the QC results. Finally, you should know that there are some factors can affect the analytical test.